So you are starting extraction of aluminium. By electrolysis process. Okay, the ore that is used over here is Al.2O3, that is alumina, okay, which is obtained by Bayer's process. Now the melting point of aluminium oxide is about 2000 degrees Celsius, that is 2050 degrees Celsius. Okay, now we cannot carry out electrolysis at such a high temperature. Okay, it will increase the cost, and it is also difficult to carry out electrolysis at such a high temperature. So we are going to add a few things which is going to improve the electrolysis conditions. Which are these substances added? The first substance that is added is cryolite. Okay, that is Na3Al(F6). Now in addition of these substances, the melting point of alumina, that is Al2O3, okay, it's the mixture is having melting points 950 degrees Celsius, okay, which becomes below 1000 degrees Celsius. So addition of cryolite will bring down the melting point of Al2O3 to 950 degrees Celsius. So this mixture will have the melting point 950 degrees Celsius. Apart from this, one more substance is added, that is fluorspar, Fluorspar. Okay, this is calcium fluoride, that is CaF2. Okay, the purpose of adding fluorspar is CaF2 improves electrical conductivity. This is the purpose of adding calcium fluoride. Now the next part that we will see will be the reactions. Okay, first of all we will consider all the dissociation reactions of all the substances. We have, first thing is our ore, that is Al2O3. It is going to dissociate into aluminium ions. Valency of aluminium is 3+, and oxide valency is 2-. There are 2 aluminium ions formed, and there will be 3 oxide ions formed. Okay, the other substance is Na3Al(F6), that is cryolite. It will split into sodium ions, aluminium ions, and fluoride ions. Okay, the balancing is simple. You can see 3 sodium are there, so 3 Na+, there is only 1 Al, and there will be 6 fluoride. Total charge also has to be balanced on both the sides. You can see on the left side there is no net charge. This is having charge 3+. Aluminium is also having charge 3+, and fluoride will have charge 6-. Okay, so net charge on the right side is also 0. For this equation also 2 3s are 6 positive and 3 2s are 6 negative, and on the left side also you can see there is no net charge. The other substance that is there is CaF2, that is calcium fluoride. This is going to split up or ionize, dissociate into Ca2+ and fluoride ions. You can balance it. Okay, so charge is 2+ over here, and here it is 2-. Now these are all the dissociation reactions for extraction of aluminium. Now we'll have to consider the activity series of metals. We have here aluminium, sodium, and calcium. You can see out of these 3 metals, aluminium is the lowermost metal amongst these 3. Therefore only aluminium ions will get discharged at the electrode. The electrode is going to be, all these are cations, so these will move towards cathode. Okay, which is going to be the negative electrodes. Then the anions that are present are oxide and fluoride. Obviously oxide is below fluoride, so oxide ions will get discharged, This is an anion, so it will get discharged at anode, okay, which is going to be the positive electrode. Okay, now the reactions at cathode. Okay, aluminium is there, Al3 plus, it will gain 3 electrons, it will become aluminium. This aluminium is in the molten form, okay, or molten state. Then at anode, oxide ions are there, it will lose 2 electrons, okay, and it is going to form oxygen atom. This oxygen atom obviously will combine with another oxygen atom and it will become oxygen gas. Okay, now this oxygen gas will react with anode, which is made up of graphite. Okay, graphite basically is carbon. Okay, so this carbon, that is graphite, will combine with oxygen, it will produce carbon dioxide. So what basically happens to the anode? Slowly the anode gets eaten away by oxygen by means of chemical reaction. It will form carbon dioxide. Yeah, so after every few days or periodically you will have to replace the graphite anode. So that is one of the give reason questions. The cathode is made up of steel. Okay, we will just see the electrolytic vessel first. Before going into that, I will just give you the overall reaction. Okay, Al2O3 is there. The overall reaction of electrolysis, it gives you aluminium plus oxygen. This is formed at cathode, aluminium, and oxygen is formed at anode. Okay, you can balance this equation. This is 3 over here. Make this an even number. 2 3s are 6, 3 2s are 6, and there will be 4 aluminium. So this is the balanced equation for